Okay, continuing on. So we were talking about list comprehension. So far, we have seen many of the ideas about using loops in our code. Python prides itself on allowing programmers to write clean and elegant code. We've already seen this with Python giving us the ability to write while and for loops in a single line. In this exercise, we're going to examine another way we can write elegant loops in our programs using list comprehensions. To start, let's say we had a list of integers and wanted to create a list where each element is doubled. We could accomplish this using a for loop and a new list called doubled. Take a quick look at that code. Okay, moving on. List comprehensions, conditionals. List comprehensions are very flexible. We even can expand our examples to incorporate conditional logic. Suppose we wanted to double only our negative numbers from our previous numbers list. We will start by using a for loop and a list called only negative doubled. Only the negative numbers doubled. So let's take a look at this code. We have numbers, and we've assigned to it this list with 2, -1, 79, 33, -45. So we've got two negative numbers hidden in there. And we've said there's another list called only negative doubled, and we'll assign to that these blank square brackets. Here's a for in loop. For num in numbers, if num is less than 0, only negative doubled, so that's the name of our list, dot append. But what we're actually appending to only negative doubled is num multiplied by 2. So the double of the temporary variable. And then we're going to print what we've created. We're going to print only negative doubled, the list that we did the append method on. And what we'd get as the output is -2 and -90. Does that make sense to you? Why -2? Because when we multiply -1 by 2, we get -2. When we multiply -45 by 2, we get -90. So doubling this gives us -2, doubling this gives us -90, so our output contains -2 and -90. Now here is what our code would look like using a list comprehension. So this idea of packing it all into the square brackets, the expression and the for in construction, that structuring of the characters is what it is to use a list comprehension. So negative doubled is going to have assigned to it num multiplied by 2, and of course at this point num shouldn't mean anything to you. It doesn't mean anything. You know, it's not defined on this line, num, it's not defined yet on this line. So we're kind of putting a foot forward here. Num multiplied by 2 for num in numbers. Okay, now it's defined. Now we can see that it's the temporary variable in our for in loop. For num in numbers, if num is less than 0, if num is the number's negative, in other words. So for in if. And all that achieves the same result. It would output the same result. We'd have a list with -2 and -90. Let's read. In our negative doubled example, our list comprehension, 1 takes an element in the list numbers, 2 it assigns that element to a variable called num, 3 it checks if the condition num is less than 0 is met by the element stored in num. If so, it goes to step 4. Otherwise it skips it and goes to the next element in the list. 4. It applies the expression number multiplied by 2 on the element stored in num, and adds the result to a new list called negative doubled. because it says, remember, the whole set of square brackets and their contents are being assigned to negative doubled. Never forget that. So it applies the expression num multiplied by 2 on the element stored in num, and it adds the result to a new list called negative doubled. 5. Repeats steps 1 to 3 and sometimes 4 for each remaining element in the numbers list. So 1 to 3. So it takes an element in the list of numbers, assigns it to a variable called num, that's our temporary variable, does that again, and then it also checks the condition that if num is less than 0. So it does that over and over again for each of the elements within the list numbers. We can also use if-else conditions directly in our comprehensions. For example, let's say we wanted to double every negative number, but triple all positive numbers. Here is what our code might look like. Numbers has assigned to it 2, minus 1, 79, 33, minus 45, and doubled has assigned to it num multiplied by 2 if num is less than 0, else num multiplied by 3 for num in numbers. And this would output 6 minus 2, 237, 99 minus 90. Again, it's a bit jarring, because a bit strange to look at, because it's as if the body of the loop is before we've said we've got a for in loop. So the for in structure comes here, and we have the body of the loop before that. If the number, the temporary variable, is negative, also what's strange is we're saying what the action before the if statement. So we're saying, because normally in English we'd say if the number is less than 0, then multiply number by 2. But here we're saying multiply number by 2 if the number is less than 0. So we're setting out the condition after we've said what the action is. So we're saying number multiplied by 2 if number is less than 0, else number multiplied by 3. So one action, another action. So action if, condition, else, second action, for num in numbers. Note, this is a bit different than our previous comprehension, since the conditional, if num is less than 0, else num multiplied by 3, comes after the expression num multiplied by 2, as we pointed out, but before our for keyword. The placement of the conditional expression within the comprehension is dependent on whether or not an else clause is used. Yeah, absolutely. So the fact that we have else really changes things around. As I said, here what we're saying is number multiplied by 2 if the number is negative. It's a strange ordering, and that's to do with the fact that the else is here. Because usually, so we say the action first, usually if we look at this comprehension, okay, no, I suppose there's no condition here. Oh no, yes, okay, so here we have the action. We do have the action first, like before, number multiplied by 2, and if you're thinking it's on the previous pattern, you might be thinking, if what? If what? Number multiplied by 2 if, because down here it goes number multiplied by 2 if it's negative. Whereas up here, it just goes number multiplied by 2, and then it doesn't tell us. There's no if. It does for num in numbers if the number is negative. So here it's as if the action or the consequent and the antecedent, the condition, is sort of flanking the for in construct. Whereas down here, when we're doing this doubling, tripling malarkey, we say action and the condition, let's specify them both before we get to the for in construct. We don't have the action here and the condition after. We move the if statement right to the front. We say number multiplied by 2 please if the number's negative, else number multiplied by 3. So there's something about the fact that when we're specifying two alternative actions, because you're either going to be multiplying the number by 3 or the number by 2, something about the fact that we're doing that means we want to kind of keep the condition there, right next to them, and make it clear that it's number multiplied by 2 if it's negative, else please multiply that number by 3. And now let's just give all we have left to do is give the for in construct. So note, this is a bit different than our previous comprehension, since, well, the conditional if number is less than 0, else number multiplied by 3 comes after the expression number multiplied by 2 and before the for keyword. Exactly, we've got it all up front. The placement of the conditional expression, meaning the if expression, the placement of the conditional expression within the comprehension, yeah, that will depend on whether or not an else clause is used. So we might set the slogan would be, if you've got an else clause, get the if right up to the front. I don't know. It's not very catchy, but that's what we're saying. If the else clause is used, have that if expression right near the front, next to the else. When an if statement is used without else, the conditional must go after the for in construct. If the conditional expression includes an else clause, the conditional must go before the for construct, as we said. Attempting to write the expressions in any other order will result in a syntax error. Here are a few list comprehensions in a single block. Take a moment to compare how the syntax must change depending on whether or not an else clause is included. So we say, let's have a list called numbers, and we've assigned to it 2, -1, 79, 33, and -45. So we've got 1, 2, 3 positive numbers. We've got a -1 in there and a -45 in there. Now let's take our time with this. So it says no if, no underscore if. That's just the name of a list, because here we have a list comprehension. Num multiplied by 2 for num in numbers. Okay, so very simple stuff there. An expression and a for in. Num multiplied by 2 for num in numbers if the number is negative, less than 0, and not 0 itself. And then we've got num multiplied by 2 if num is less than 0, else num multiplied by 3 for num in numbers. And so you can see there, because we've got two different actions, sort of separated by the else, number multiplied by 2 or number multiplied by 3, we like to put the if statement sort of between the two actions, right up at the front, and then in the final part of the square bracket filling, we have the for in construct. So we might say else elevates everything to the front. That's a nice thing to remember. Else elevates everything to the front, to the top of the square brackets, including the if statement. Action if else, and another action. for in. Now, let's write our own list comprehensions with conditionals. Instructions. We have defined a list of heights of visitors to a theme park. In order to ride the topsy-turvy Tumbletron roller coaster, you need to be above 161 centimeters. Using a list comprehension, create a new list called Can Ride Coaster that has every element from heights that's greater than 161. So we're going to use a list comprehension, meaning we're going to have those square brackets with the expression tucked at the beginning of it. So the new list has got to be called Can Ride Coaster. So let's begin with that. Can Ride Coaster. And we're going to assign to it some value, and we're going to use a list comprehension. So I've put square brackets. And I'm going to start actually by writing the for in construct, which will probably go right at the end. So I'm going to put for height in heights. Now I can put my expression near the beginning of the brackets. So it's going to be something like height, our temporary variable, greater than 161, but just to say what I'm thinking, how do I communicate the fact that I want that height to be kind of put into the into heights? Height is bigger than 161. Do I need to kind of say if height is bigger than 161, how put it in this list? How do I say put it in this list? So let's look at what we've learned. Well, we had an example involving num multiplied by 2. Maybe that's it. If height is bigger than 161 for height in heights, we're already saying we want the list to be called Can Ride Coaster, so it's implicit that we want a list to be created. Let's try run, and no, we get a syntax error. So it seems like you've encountered a syntax error due to an invalid syntax in your code. The error is likely caused by a missing closing bracket in line 3. I'm not sure. The list comprehension is not properly closed, which is causing a syntax error. You should add a closing bracket at the end of the list comprehension to fix the error. Here is an example of how to fix line 3. So they're saying put height and then the for in construct if height is right. So again, it is a bit of a strange way of speaking. The way of saying fill this with the heights is you just put height. And then as for saying that you're only interested in heights bigger than 161, we add the if statement on the end. If, and you thought the if statement could go at the beginning, just like with an else, but there's no else here, so you needed to put the if statement at the end. So there's two things there that we didn't really appreciate. One, the fact that you just put height. Right, that is how you say, I want you to fill this list Can Ride Coaster with the height elements. Height for height in heights. and then the fact that the if statement, if height is bigger than 161, goes at the end. So is that better? And we need to print can ride coaster. So we need another line where we say print the new list, which has come about by comprehending heights, and it's called can ride coaster. Perfect, and we've got 164, they can ride. That makes sense, doesn't it? 170, 163, 163. Review. Good job. In this lesson you learned how to write a for loop, how to use range in a loop, how to write a while loop, what infinite loops are and how to avoid them, how to control loops using break and continue, and how to write elegant loops as list comprehensions. Let's get some more practice with these concepts. Instructions. 1. Create a list called single digits that consists of the numbers 0 to 9 inclusive. Okay, so I'll say single digits and assign to it, well, we'll use range 0 to 9, so we want, here we go, let's say 10 elements. Correct. How would we remember that? How would we remember that range deals with the numbers of things there are? I don't know, range. You could think of someone on a shooting range and they're shooting T-Rexes, the big dinosaurs all stomping away in the distance, and your job is to take them down. And you might think Rex, because range and X, existence. Range deals with existence. We want 10 elements to come into existence. We're not so this 10 is not because we're going to have a 10th element, which would mean there are 11 overall. It's because there are 10 in existence. X. Think of Rex when you think of range, those dinosaurs on the range. It deals with how many things in existence. 2. Create a loop that goes through single digits, the list we just created, and prints out each one. Well, we can do a for in loop for this. For digit in, that's just an arbitrary name, for digit in single digits, colon, print digit. That seems okay. Oh no. I spelt single digits wrong. Click run. And now we've got a tick. 3. Before the loop, create a list called squares. Assign it to be an empty list to begin with. So before the loop, so I'm going to say squares equals, checking I'm spelling squares correctly, and then some blanked out square brackets, and we've got a tick now. 4. Inside the loop that iterates through single digits, append the squared value of each element of single digits to the list squares. You can do this before or after printing the element. So inside the loop that iterates through single digits, so we're not going to use a list comprehension. So inside this loop, I'm going to do it before we print digit. So I'm going to say, so we need to do digit squared. So I can do, that means to the power of 2. So I'm going to do up and then 2. Is that right? Digit multiplied, or to the power of 2. And we want to append that value to the list squares. So I'm going to do squares dot append digit multiplied by 2. So I'm going to get rid of that. Squares dot append digit multiplied by 2. Is that right? Inside the loop, yeah, that iterates through single digits, I'm using the right temporary variable, digit. That's what we defined here, digit for digit in single digits. Let's click run, and we got that wrong. The value for squares did not match 0. Value for squares did not match 01496. It was 02468. Yeah, that will be the squares of them. Oh. No, because I was thinking maybe you want me to append it to single digits and put them in there, but no, it does say append the squared value to the list squares. Let's view the solution. So they do squares.append item **2. Okay, so we did multiplied by 2. Right, that is not squaring. You need to do **, meaning to the power of 2. You plonker. 5. After the for loop, print out squares. Okay, so back with the indentation and then print squares. Perfect. 1, 4, 9, 16, 25, 36, 49, 64 and 81. 81 is 9 squared. Yep. 8 by 8 is 64. Number 6. Create the list cubes using a list comprehension on the single digits list. Each element of cubes should be an element of single digits taken to the third power. So I'm going to type cubes equals and then sketch out my square brackets because I'm using a list comprehension. And I'm already thinking, okay, I'm going to tuck in an expression on the left hand side here and I'm going to put a for in loop here. So I'm going to say digit again. I'm going to use that as my prop for digit in single digits. And remember, where are you going to put the if condition if you're going to use an if condition? Maybe not here. So I'm going to say digit to the power of, so **. We're not multiplying by 3. We're not multiplying by 3. We're cubing. So ** 3. So what's happening now? I've got digit multiplied by 3, space, 4, digit in single digits. Is there anything that I need that's correct or incorrect with this? Create the list cubes using a list comprehension on the single digits list. Each element of cubes should be an element of single digits taken to the third power. Well, I'm going to put a print statement in, print cubes, and see if, no, okay. It says cubes equals digit to the power of 3 for digit in single digits, and it's put the arrows here at digits. Oh my word, putting in underscore. Okay, good. We now seem to have the correct result. We know that this range, just to recap, this range function, think range, rex, existence. It brings 10 things into existence, which means we'll have a 9th element, not a 10th element. We'll have a 9th element and a 0th element. And so the 0th element in this rex range 10 function is going to be 0. What's 0 multiplied by 0 multiplied by 0? 0. Okay, the answer to 0 cubed is 0. So that's correct. That I expect to see a 0 here as the first element in my output. The first element in this, which is returned by this range function, is going to be the number 1. And what's 1 cubed? The answer is 1. 1 multiplied by 1 multiplied by 1 is 1. So I expect to see that. The next element is going to be 2. That's the 0 for second element. The second element is going to be the number 2. And 2 cubed gives me 8. Okay, so 2 multiplied by 2 is 4. Multiplied by 2 again is 8. So I expect to see that. So everything's working in that regard. 7 says print cubes. Good job. So if I click run, we've now got a tick on 7. And that is that complete. Lesson complete. What would be the output of the following code? So we've got a for in loop and we're printing the temporary variable. So we're just going to print everything in it. Coffee, tea, water, juice and soda. But this is a good question. Do we print the list? So do we print something with square brackets and speech marks, or do we just print coffee with no speech marks, no square bracket? I think we do this. It's bare. It's actually bare, because it's not seeing the list. The for in loop is going into the list and going through each of the elements themselves. So it's this one, yeah. Because we don't actually mention, well, we do mention the list in the for in structure, don't we? But we don't. But we also mention something that's going to represent the element inside the list. Fill in the code to loop over the list, which is called grouped topics, and print every element in the list. So grouped topics has assigned to it this structure, and we have one element, which is a list, and a second element, which is a list. So in terms of existence, we have two things in existence, but if we're using counting words, we have the zeroth and the first. So algorithms, data structures, AI, linear regression, SQL. For sublist in gap, for sublist element in gap, print something. So for sublist in, well, we need to refer to a collection, and the name of the collection we can see here is grouped topics, so I'm going to put grouped topics there. For sublist element, again, that can be anything. That's just what sublist element is, just what they happen to have decided to call their prop, their temporary variable. So for sublist element in, well, this is a for loop, a for in loop within a for in loop. So what I want to do is not go in group topics again, but go into the sublists. So I want to go into sublist. So for sublist element in, well, again, I'm not going to refer to group topics again, but I can refer to this prop, because this is a prop we've used to represent the internal lists. So I'm going to say sublist again. For sublist element in sublist, print sublist element. What would be the output of the following code? Numbers has assigned to it 2, 4, 6, 8. Who do we appreciate? For number, not numbers, for number in numbers, print hello. So this is a great question, because it reminds us that even though we're printing sort of on behalf of every element in the list, we don't actually have to print the element itself. What we're doing here is printing hello on behalf of the 2, printing hello on behalf of the 4, on behalf of the 6, and on the 8. So we're printing hello 4 times. So you can see it's going to be this option. Which of these list comprehensions, meaning instructions within square brackets for creating a list, I suppose yeah, that's why it's called a list comprehension. Because you're putting your understanding of the list within the square brackets, your comprehension of the list. What is it? What is this about? You know, is it all the elements taken from somewhere else multiplied by 2? How do you comprehend this list? So you're putting the list into abstract terms. Anyway, so which of these list comprehensions will create a list which is equal to desired list? So if we look at desired list, it's got in it 10, 8, and 20. So how are we going to end up with that? We could say I for 4 in. So there's the 4 in construct. So for I in my list, just put I. Remember, that's how it's done. It's kind of it takes you by surprise how brutal it is. But that is enough. You just plonk down the temporary variable, space, and then put the for in construct. So I for in. I plus 5 for I in my list. Well, is that going to work? If we take the elements in my list and plus 5, well, that will turn into 10, the 5. That will turn into 15. That will turn into 3. Okay, that's not what we're doing. I for I in my list, if I is bigger than 10. Well, that's not going to work because 8 is in the output and 8 is not bigger than 10. What about this one? For I in my list, if I is bigger than 5. That could work because 10 is bigger than 5 and 8 is bigger than 5 and 20 is bigger than 5. So they are all bigger than 5. And everything that's been left out of desired list, which is also in my list, namely -2, because there's no -2 here, and 5, well, those are all things which are either 5 or smaller than 5. So maybe that is the rule. If I is bigger than 5, and that would make sense. So notice again how the if statement is at the end in the gutter. So I for I in my list, and then put the if statement at the end. If there's an else, the if statement would come up near here at the beginning. What would be the output of the following code? Numbers has assigned to it 1, 1, 2, 3. For number in numbers, colon, if number %2, we have that comparator operator 0, colon. Right, so that's checking. Is 2, well, no. First of all, number modulus 2, that's what the percentage sign means. So modulus means divide and see what the remainder is. So if number was 10, this expression would collapse to 0 because 10 divided by 2 is 5. There's no remainder. But if we were to say number is 3 and we do 3 divided by 2, well, then we kind of can fit 2 in once, and then we have a 1 left over, don't we? So that would be 1, right? 3 modulo 2 would be 1. So there are some numbers that do create a number with that expression, number %2. This is a comparison operator, so we're checking, is this expression of the same value as 0? Is it 0? Is number modulus 2 0? Now, if it is, stop. Terminate the loop. Terminate the loop. Don't just terminate your moving through this iteration. Terminate the whole loop as well. Okay. But let's suppose we do number modulus 2 and it's not 0. For example, as I said, 3 or 5, because 5 divided by 2 is kind of 2, and then 1 left over. So in that case, well, no, it's not equal to 0. There is a substantial remainder. So we don't go into the break line. We carry on and we print the number. So basically what I'm expecting here is any number that's kind of like 3 or 5 is going to keep the loop going. But if I have an even number like 2 or 4 or 6, where when we divide it by 2 we do have it equal to 0, that's going to bring the loop to an end. So if we've got 1 1, 2. So 1's not gonna... Well, okay, so what is 1 divided by 2? It's 0.5. Well, that's not equal to 0, so we'll keep going. Next element, 1. Well, let's do 1 divided by 2. Well, that's 0.5. That's not equal to 2, so go on to the next line and print 1. So we've now got a 1 printed and another 1 printed. We move on to the next element, which is a 2. See? 2. So that becomes our value for number at this point in time, right? This is our time variable, our temporary variable. So if 2 divided by 2, modulus 2 comes, well, that is 0. No. What is... Oh yeah, modulus means if there's a range. So 2 modulus 2 comes back with 0. Okay, now break. And we're not actually ever going to get to the print number. That's my understanding of it anyway. So I think... Or am I right though? Maybe it breaks, but it also does this line too. Maybe break means break the loop overall, but finish this iteration, for goodness sake. Maybe that's what break means. But for my money, I'm going to say it's a proper clean break. It doesn't just break the loop, it stops you from continuing to the print line. So I think that the output will be 1 and 1. Phew, yeah. Break means break. It's doubly strong. Break means break. What would be the output of the following code for I in range of 3? Remember, range, rex, existence. Print I. Well, again, we're printing the prop. We're printing the variable. But remember, it's a temporary variable is a type of variable, so we will be printing the value that it has at that point in time. So we'll have 0, 1, and 2 in this range. Remember, 3 things in existence. So 0, 1, and 2. So yes, we're printing I, but we're not printing a literal I. We're printing I, the variable. So I will at one point in time stand for the 0, then the next moment it will stand for the 1, and then the next moment it will stand for the 2. Remember, we have a 0, 1 and a 2 in this. So that's what we'll get printed. 0, 1 and 2. Which of these list comprehensions will create a list equal to desired list? So let's look at desired list first. So we're going to assign to this -1, 0, 1, 2, 3. Well, look at that. They do all go in... they have an equal interval between all the elements. And they're consecutive. They're also in order. So how are we going to end up with that? So range, feed in 5. So we're going to have 5 things. Well, we do have 5 things here. 5 things in existence. Think of Rex and shooting dinosaurs on the shooting range. But the problem is, range, if you say you want 5 things, it actually makes the first thing, it gives you B 0. So it doesn't start -1, it starts 0. So it's not going to be that option. Desired list has assigned to it these emptied out brackets, and we have a for in construct. For I in range of 5, which is fine, desired list is going to be is going to have assigned to it that temporary prop take away 1. Well, that does look like it works, because 0 take away 1 will give us our -1. Range gives us 0, so we will have -1. Range next gives us 1. Well, if we take away that, we'll get 0, and so on. Let's just check out the other options for completeness. We have a for in construct for I in range 5. Again, range 5 is fine. At the beginning it says I take away 1. That looks good. You know, that looks good. We've got I take away 1, just like we have I take away 1 here. This fourth option I have to rule out because, as I said, range 5 will start at 0 and there's no way that this is going to generate -1. We don't have I -1, so that's just not going to do it. The only thing I can think of that's a disadvantage of this option here is that we don't have anywhere that actually says this list is going to have the name desired list, and that is the only thing I can think that's wrong with that. So I'm going to go for this option, which is using this sort of less elegant syntax where we put these blank brackets and then refer to desired list. Okay, so this will produce the right list, but this is not a list comprehension, so this is the correct answer. Okay. What would be the output of the following code? Numbers 1, 1, 2, 3. For number in numbers, colon. And then we have a condition. If number modulus 2 is equal to 0, then we're going to continue, print number. Well, let's go through. Well, 1 divided by 2 is going to be 0.5. So we don't continue, but we go to the next statement anyway and print number. What I'm saying is it's not that we do continue, but that said, it's not that we do follow this particular continue command. But on the other hand, we don't need a continue command to go to every statement in the body of the loop. So we will print that number. 1 divided by 2 is going to be 0.5. Actually, I'm just wondering, does that mean, because usually the whole concept of modulus is usually explained in terms of remainders. So that's a classic example. They'll say something like 3 divided by 2 is 1 remainder 1, because we can fit 2 in, but then there's 1 left over. But what if it's like 1 divided by 2? There's no remainder, is there? If it's... So do we say there's a remainder of 0.5? No, we don't. We say we do fit 2 in 0.5 times, but there's something that seems a bit odd about saying that. I'm going to say that doesn't satisfy the condition. 2 divided by 2. Well, that is equal to 0, so that will continue. I think we'll get 3 divided by 2. 3 divided by 2 is 1 remainder 1, so that's not equal to 0, but we'll still print that anyway. We'll still print number anyway. I think we'll just get 1, 1, 2, 3. Okay, that's not an answer option. 1 divided by 2 is 0.5. So if we take this and divide it by 2, we'll get 0.5. If we take this and divide it by 2, we'll get 0.5. However, this is not just division. The question is, what does 1 modulus 2 give us? I think 1 modulus 2, perhaps it gives us 0.5. No, it doesn't give us 0.5. Because if it did, well, it could. So what's interesting about this example is we print either way. We print if we do follow this continue command, and we print if we don't get the continue command. No, right, okay, no, listen, you've misunderstood. So this is what we were talking about with break, really. We said break breaks two things. One, it breaks the continuation of the iteration, the given iteration, and secondly, it breaks the loop. So it means that not only have we brought this iteration to an early stop, but it will be the last iteration. So there's two levels in which that operates. And there's a similar point to be made about continue. So if we do, I think that what happens is if we do hit this continue, because number modulus 2 is 0, and that of course happens with 2 divided by 2, there's no remainder, so we get a value of 0 here. We execute the continue. I think what that does, it means we move on to the next iteration. We abandon this given iteration, so we don't print 2. So I think what we get is 113. Now, if that's the case, that I think we need to remember that really intentionally. So we need to remember that what continue does is it continues moving across the iterations, but what it doesn't do is continue moving across the given iteration. So as weird as this sounds, continue sort of brutally continues, right? It drags you along. Continue drags you along. It violently continues. So it abandons the rest of the statements in the current iteration. So that you need to remember that. Check am I right? You're right. Yeah. So when the loop reaches the element 2, it passes to the next number before it's even printed it, right? It violently continues. So fear this command. It does not mean, even though it's called continue, we're going to continue with the statements in this iteration. No. So it violently continues. That's motto of the day. What would be the output of the following code? For I, in range 3, think of someone on a shooting range shooting T-Rexes. X, it deals with existence. So we have a 0th element, which is 0, a first element, which is 1, and a 2, a number 2, which is the second element. So for I, in range, print 5. That looks really... So print 5. I mean, I know we can put a string as the argument for a print function. What does that mean? Print 5. Well, again, remember, what we're doing is printing on behalf of each element. I think what we're going to do is print a 5, because it's okay to have a numeric data type. That's all. It doesn't have to be in speech marks. We're still going to print a 5 though. So on behalf of the 0, we're going to print a 5. On behalf of the 1, we're going to print a 5. And on behalf of the 2, we're going to print a 5. So we're going to have 5, 5, 5. Correct. Fill in the blank with the appropriate while condition in order to print the numbers 1 through 10 in order. I will assign to I 1. And then they've put, and we haven't really seen this, but underscore underscore blank and then underscore underscore. That's very dramatic, isn't it? It's like blank is stood center stage. That's the equivalent in code of standing in a stage with a spotlight on you and having nothing else lit up on the stage. And then we've got 2 lines indented below that. Print I, which is the variable up here, which we assigned 1 to. And then the next line says I plus equals, which is like, you should really look at that like a sword stabbing onto the 1 to sort of make it part of the pile. So that's I with 1 added onto it. So that means I will become 2, right? I had a value of 1. We'll now add a number on to it. I is now 2. So to summarize again, we have 2 statements. We're going to print I, and then we're going to increase the value of I by 1. It's called incrementing it. I'm not sure what that is doing, that line. What is that doing? Fill in the blank. Oh, okay. So this is just the line we have to fill in. I got you. Fill in the blank with the appropriate while condition in order to print the numbers 1 through 10 in order. While I is less than 10, colon, Well, we want to print the numbers 1 through 10, and remember, that means include 1 and include 10, so it's not going to be that. We've got while I is equal to range 11. Range, Rex 11 things in existence. While I is equal to... I'm not sure about that. I'm understanding I mean it's a variable, it's 1, it's 2, but it's not the whole range. This is like saying I is the whole range. While I is less than or equal to 10, that looks better because we want to print the numbers 1 through 10. So we want everything under 10 and 10, so that looks pretty good. And the next option says while I is bigger than 10. Well, no, that doesn't make sense. And that was the correct option. Correct, this will print the counter and then increase the counter by 1 until the counter is 11 and the loop body is not entered. So yeah, we need... In order to get a loop to print the numbers 1 through 10, we need this action line. We need a line where we say, okay, because we've printed I, which was 1, you now need to change it into 2, so that when the loop executes again, we're printing 2 instead. So there's a kind of record what it is, change it, ready for the next iteration. Record what it is, change it, ready for the next iteration. But of course that is something that will be infinite, so you have to put that check in place. So we use a while loop and we say, well, just keep kind of going with that recipe, but we'll put a limit on it, because otherwise it'll just get to 10 and it'll print 10 and then make it 11 and then make it print 11, make it 12. So we have to say while I is less than or equal to 10, and that's the use of while loops. They're kind of limiters. So if we're really thinking about this abstractly, if you just sit me down and say, why are while loops useful? I'd say you want to repeatedly do something, but you also want a kind of built-in limit. It's like saying to someone, I want you to chop these vegetables for the next hour, and you want some way to make them stop at 6 o'clock, but you do want them to sort of uniformly chop during that hour. And that means you'll generate something. You'll generate, a bowl of chopped tomatoes or a bowl of chopped up chips. These uniform, regular things. They're all the same, aren't they? Like, we wanted the numbers 1 through 10. They're all the same, and they're all arrived at with the same little procedure. But we want a kind of limit around those generated things. And that's what we get we can put in place with a while loop. While our prop is less than or equal to 10, print and increase, print and increase. So that's the quiz on loops complete, and we got one question wrong, and we got it wrong because we didn't pay attention to what a list comprehension is. A list comprehension has the for in construct and the expression using the prop, using the temporary variable in the square brackets. Okay, send it there.